Now I am going to explain about the issues in a decision tree learning. Okay, previous class we have discussed in the how to construct a decision tree, what do you mean by decision tree, how to represent a decision tree, what are the leaf nodes and what are the root node in the decision tree. Okay, by using a what is the ID3 algorithm, ID3 algorithm states. Last class we have discussed these are the topics in the last class. Okay, in this class we have discussed in the we are discussing the issues in a decision tree learning. Okay, here overfitting reduce the error pruning and rule post pruning, and one more is the extension to continuous value attributes and alternative measure for a selecting attributes. Okay, handling the training examples with missing attribute values and handling the attributes with a different cost, improving the computational efficiency, And next one is the overfitting definition, a formal definition of the overfitting definition. For here constructing the decision tree that adapt the too much to the training examples may lead to overfitting. Consider the error hypothesis. Here the error hypothesis is represented as a small h power. Okay, training data. Here the set of in our data set have the 14 training example. That 14 training example is represented as the capital D. Okay, training data error of D, error of base D and H. Okay, this is the empirical error in the overfitting. Okay, entire distribution of next one is the entire distribution of instance space. Okay, instance is represented as the small x, instance space is represented as the capital X of data. Here the error of instance space is the error of instance space of hypothesis. This is the expected error. Okay, hypothesis space, hypothesis is the H, overfit training data in overfit training data. If there is an alternative hypothesis, H dash is belongs to the hypothesis space. Hypothesis space means set of hypotheses in the hypothesis space, such that here the error of training data that is the hypothesis is less than or equal to error of training data in the another alternative hypothesis is the H dash, and error of instance space hypothesis is less than or equal to error of instance space hypothesis is the H. Okay, that is behaves the better of unseen data. This is our training data. In this data we have a four attributes, and last one is the prediction and outcomes of these attributes. Here the 14 example, and last one is the 15th one. Here we are finding the whether playing the tennis or not, based on the attributes. That attributes are the outlook equal to sunny and temperature equal to hot and humidity equal to normal and wind equal to strong. Okay, wind equal to strong. This is our decision tree. First one is the root node. This is the first one, highest gain value is the outlook, and next attribute is the sunny. Next attribute is the humidity and high and normal. Same also here also rain other attribute is the windy. Okay, here the strong and weak. Okay, first one write the outlook equal to sunny, temperature equal to hot and humidity equal to normal, wind equal to strong, play the tennis equal to no. Here this data is fitting into the decision tree. New noise examples causes splitting the second leaf node. Okay, second leaf node, and this is the graphically representation of the overfitting decision tree learning. On training data, first one, this line indicating the training data and dotted line indicating on the test. This is the accuracy of the data set. This is the size of the tree. Here the size of the tree. These are the set of training example. These are the nodes. Okay, and avoiding the overfitting decision tree. In a decision tree, here the two strategies to avoid the overfitting decision tree. Stop growing the tree tree earlier before the perfect classification and allow the tree overfit the data. First one is the stop the growing, and second one is the allow the tree overfit. Allow the overfit. These are the two strategies for avoiding the overfitting the data. And next one, training and validation set. Here the Reduce the error pruning and role pruning. Reduce the error pruning and role pruning. The other approaches use a statistical stress to estimating effect of the expanding or pruning. Okay. Minimum description length principle uses a measure of complexity of encoding the decision tree and the examples, and the halt growing the tree when the encoding the size is minimal. Size is minimal. This is the reduced error pruning. Each node is a candidate for a pruning. Pruning consists of removing the subtree rooted in the node. Okay, the node becomes a leaf node and assigned the most common classification. Nodes are removed only if the resulting tree performs to no goes on the validation set. Okay, and last one here, the pruning stops when no pruning, increasing accuracy. Increasing effective of reducing the error pruning. Okay, here reducing the error pruning, graphical representation, accuracy and size of tree, and training data. This one is the line. This line indicating the training data, and one on test data dotted lines, small dotted lines, and one test data on test data is the small dotted lines. Okay. Next one, rule post pruning. Okay, rule post pruning. Decision tree is converted into the set of rows. Decision tree is converted into the set of rows. First one to create the decision tree. Okay, first one to create a decision tree from a data set, training data set. Okay, convert the tree into a equivalent set of rows. Convert a tree into a set of equivalent rows. Okay, each path corresponding to a one rule, and each node along a path corresponding to a precondition. Each leaf classification to the post condition. Okay, post condition. And for third one, here the generalize the each rule by removing those preconditions whose removal improves accuracy. Okay, which one is the improves the accuracy. Okay, our validation set and or the training with a pessimistic and statistically inspired and measure. Okay, and start the rules in a estimated order of accuracy and consider them is sequence when the classifying the new instances. When the classifying new instance, this is our decision tree is converting into the set of rules. Here the first one is the root tree. Here the node is the outlook equal to sunny and outlook equal to sunny and humidity equal to high. Humidity equal to high. Then here the next one, here the condition is the play tennis is the no. Play the tennis is the no condition. And next rule is the outlook equal to sunny and humidity equal to normal, and play the tennis is the yes condition. Okay, if the outlook equal to overcast, play the tennis yes. Okay, and next rule, and one more rule is the outlook equal to rainy, and then wind equal to strong, and play the tennis is the no. And next one is the outlook equal to rainy and wind equal to the weak, and play the tennis is the yes. This is the set of rules based on the decision tree. Why converting the rules? Each distinct path produces a different rule. Condition removed by may be based on a local criterion. Node pruning is a global and affect all the rules. Okay, converting the rules improve a readability for a humans. Okay, dealing with the continuous valued attributes. So far, discrete values, attributes and the attributes for a outcome. Given a continuous value attributes A, dynamically create a new attribute AC. AC equal to true if the condition A less than or equal to C. False otherwise. Okay. How to determine the threshold value C? Example, temperature in the play the tennis example. Here the example is the temperature. Play the tennis example. Temperature, okay, 40, 48, 60, 72, 80 and 90. Multiple of examples are in the temperature. Okay, play the tennis, no, and 40 and no, the condition is the play the tennis is the no, and 48 and play the tennis is the no, and here the yes, and one more is the yes and no. Okay, determine the condition threshold by averaging the consecutive values where there is a change in classification. Average between these two, 48 plus 60, and average between the 80 and 90. Here we are getting the average values. Here we are getting the average values. Problem is with information gain. Okay, in our decision tree construction, we have calculated the already we have discussed how to find the entropy, how to find the average information, and how to find the gain value. Okay, that gain value, information gain, one problem is there. Okay, natural bias of information gain. It's a favor attributes with many possible values. Okay, consider the attribute date. Suppose an attribute is the date in the play tennis example. Date would have the highest information gain since you perfectly separate the training data based on the date attributes. Perfectly separate the data. Okay, it would be selected at the root is the resulting in a very broad tree. Okay, a very good on the training. This tree would be performed purely in the predicting unknown instances. Or fitting, we need to look at the alternative measures. Okay, this is the alternative measures gain ratio. Here the gain ratio is the S comma A. Here the S is the entropy and A is the continuous value attribute. Okay, gain of S comma A by splitting the information. How to splitting the information? S comma A is equal to the, here formula is the minus 1 by n log base 2 and 1 by 2 plus and so on 1 by n log base 2 1 by n. Okay, here log base 2 n. We are getting a log base 2 n. Here the value is the substitute the even values. Suppose compare the continuous value attribute which is split into the data two even classes. Here the two even classes. Suppose n equal to 2. Substitute the 2 value in the splitting the information formula. Okay, here we are getting the result is the 1. Okay, and adjusting the gain ratio. Here the when the S of I in the mod S of I is equivalent to the mod S, some value I. Okay, some value I. To mitigate this effect, to following the heuristic has been used. Okay, compute the gain for the each attribute. First one is the compute the gain for the each attribute and apply the gain ratio only attributes with the gain above average. Okay, these are the problems in the decision tree learning. Handling incomplete training data. How to handle the incomplete training data in a decision tree. How to cope with the problem that the value sum of some attributes may be missing. Here the example, here the one more example is the blood test results in a medical diagnosis problem. Okay, and handling the attributes with the different cost. Here the two different costs. Here the instance attribute may have a associated cost. We would prefer the decision trees that use the low cost attributes. That is the low cost attributes. ID3 can modify to take into the account cost. Okay, here the two different accounts. First one is the gain square S comma A by cost of S comma A. That is introduced by the Schemiller. Okay, and next one is one more cost is the cost formula is the 2 power gain S comma A minus 1 by cost of continuous value attribute plus 1 power W. Here the weight is belongs to the weight is between the only 0 and 1, and this is introduced by the Nunez. These are the handling attributes with the different cost. Okay, these are the issues in the decision tree algorithm.